Welcome to the next lesson in the module on classes in Java, where we continue refining our class file and polishing our implementation. After completing this lesson, you will be able to recognize the different uses of the this keyword and use it to make your code not only correct, but more readable. You will also know how to apply two more methods commonly used on objects, toString and equals, and be able to create definitions for these methods that are suitable for your class. Once again, I encourage you to open your account and client programs in Android Studio and follow along with me as we work through the lesson. As we discussed at the outset of this module, there's a lot to learn about classes. So I encourage you not to move ahead without being confident in what we have covered so far. Reviewing videos, taking practice quizzes, and working with the files themselves are all good ways to reinforce the concepts found in this module. When we finished the previous lesson, we saw the use of the keyword this to refer to the class itself. And we also discovered that using this required some knowledge about the underlying details of how objects are created. When we use the keyword this, what we are saying is, in this object, use one of the constructors. Here, this is referring to the calling object, the implicit parameter. Let's look at the keyword this a little bit more. What else can it be used for? Here is another use. The account class has instance variables called name and number, but we may also use some of these same variable names as parameters or local variables in a method. To distinguish between them, we use the keyword this. We call this shadowing, using the same variable name from a field variable as a parameter or local variable. It makes the program more readable and allows us to use meaningful variable names. If you find this confusing, simply stick to using different variable names. Another use for the keyword this is when calling another method within the same object. Here we have a method updateBalance that uses another method, calcInterest, to do some of the work. We've seen these sorts of arrangements before, methods calling methods, in other programs. When you're calling a method within the same class, it may be helpful to use the keyword this to emphasize that you are using one of your own methods. Notice also that we made the helper method calcInterest private because it will not be used by other clients, only by the objects themselves. It doesn't need to be accessible outside of the object. To review, this refers to the implicit parameter, the object on which a method is called. Common uses for this include to call one constructor from another constructor, to refer to an instance variable, often optional, or to call another method within the class, also optional. Let's finish this lesson with two useful methods you will usually create within a class file, toString and equals. We'll start with toString. Back in your account file, add a line to print one of your objects. Run the program. What is this output? When you print an object by including it in a line of output, you are implicitly calling the current toString method. That is, you're using it without actually spelling it out. And once again, since we didn't write any toString method yet, we are using the default. The default definition for the method toString for any object is to print out the name of the object, the @ symbol, and the hexadecimal representation of the memory location where the object is stored. It's an accurate method, but for most of us, it's not going to be very useful. We can print a more useful string, but this is cumbersome every time we want to print out an account object. The common practice is to override the default definition of the toString method in the class file and make it more suitable for your object. To create our own definition of the method, we define it in the class file. The name, spelling capitalization, return type, An empty parameter list must be the same in order to override this method. For our account class, we might write something like this. To use the method in the client program, just print an object like you would any primitive data type. Now the output is much better. You could also call the toString method explicitly, but that is rarely done. Also notice I've used this here with one of the instance variables to show you how this is optional, but can make your code more readable. Now we will look at the equals method. This is another method that has a default definition. If you don't write a definition for equals in your class file, the default method will be used. It will act just like the double equals, which we've already warned you against using. If you truly are interested in how this default method works and why there are some cases where the double equals does work, wait until the lesson New Objects in Old Places, coming up later in this module. But in almost all cases, you're going to want to override the default equals method. Understanding what the default method does isn't critical in this course, but will help you to better understand what's going on. To design your own equals method for the class, you will need to decide what it means for two of your objects to be equal. It may be that you want all fields to be the same, or maybe only a few of your fields need to be the same. Perhaps you want some numeric data to be within a certain range of the other object. Whatever the case, you'll need to be able to write the conditional statements to describe equals. And note that to override this method, it must be spelled the same way, with a Boolean return type for true and false, and the input parameter must be an object. Let's take a look. Your object will call this method using another object as the input parameter. First, we will need to see if the object that is the input parameter is the same type of object as the object that made the call. In our case, we would want to make sure we are looking at another account object. If we are, then make the necessary comparisons to determine the equality according to your design. If it turned out that we weren't even looking at the same type of object, then we shouldn't even attempt to make the other comparisons. Simply return false. An account object will never be equal to a chessboard object, for example. Here is the syntax for the method definition. This would be in the account file. This method will accept any type of object for comparison. But the first thing we need to do is see if this is even an account object. For this, we use the instance of keyword. If this is an account, then we wish to continue by accessing the number field. But we can't do that with the variable other, because other is of type object, at least as far as it knows right now. Using instance of, we realized that this is an account object, so we need to cast it as an account so that we can go ahead and access or refer to its field variables. This would cause an error if we attempted to access, for example, other.number. Another thing to notice, we can directly access the fields of another account object from any method written in the class file, even though the fields may be private. We've covered a lot in this lesson, so let's quickly review. A class file should contain constructors. Every class will have a default constructor as long as no other constructors have been written. Once you begin writing constructors, you'll need to write a default if you want to use it. Every class will have accessor methods. The instance variables or fields of the class should almost always be private, so we need accessor methods to allow users of the class to access or examine these variables. Classes should also have mutators, methods that allow users to make changes to some fields. Some may simply overwrite values, while other mutator methods may actually perform checks before changing data. The toString method has a default definition, but we saw that it wasn't very useful, and that in most cases we will be overriding this method with our own definition. Overriding methods requires that we keep the same name, return type, and parameter list. A toString method will return a string that is the desired data formatted in a more user-friendly way. Finally, the equals method is usually overwritten and makes it possible to compare two objects of any type. If we discover that two objects are of the same type, the designer of the class can then check for other conditions before declaring them equal or not. It took several lessons, but we have a working class file and client file that demonstrates the many powerful features and benefits of using classes and objects to create object-oriented programs in Java. Now that you've completed this lesson, you should be able to recognize the different uses of the this keyword and know how to write definitions for the toString and equals methods for a class. As you move forward in this MOOC, here are some points to consider. First, learning the syntax of class files, how to instantiate objects, and the proper way to call methods associated with objects is only a starting point. More advanced skills, such as designing classes that are easily reused by other client programs and identifying what classes may be needed to construct an app, will take some time to develop. You can cultivate your own style of object-oriented programming by building lots of apps and reviewing apps built by others. There's a lot more we can do with classes and objects, so let's continue in the next lesson.